So, to answer the question that I asked, science is just a way of learning about the natural world around us. We do that by asking questions, doing experiments. And basically, all that it means is that we don't just guess or believe something, we test it and we collect evidence to prove that it's true. The number one goal of science is just finding out the truth about the natural world. Now, you might be asking, well, how do scientists actually do that? And there's a special method called the scientific method. Basically, what that is just a process that helps them organize their experiments and thoughts and to help them think logically. The first step is to ask questions. Basically, all that means is that you figure out what do I want to learn? What do I want to find out? The second step is to do research, which is just finding out, well, what do I already know? The third is to make a hypothesis. Sorry guys, just give me one. Okay, sorry, I'm back. The third is make a hypothesis, which is just finding out what do I think will happen. These don't have to be correct or incorrect per se. It's just what you think will happen. The fourth is to actually experiment, which is figuring out how to test your idea. After you do that, you'll just observe and collect your data. And after you get that, you'll analyze the results. And after you do all that, the final step is to draw a conclusion, which is just determining was my hypothesis correct or incorrect? Now, I know I said a lot of things, so let's try one together. So first, the question. Do plants grow faster in sunlight or shade? Let's say that your hypothesis is that plants will grow faster in sunlight. The next step would be to experiment. So in this experiment, you place one plant in the sun and you place the other plant in the shade. Now, you leave them both out for 2 weeks, and afterwards, the plant placed in direct sunlight grew 5 centimeters, and the plant placed in the shade grew 2 centimeters. What's the conclusion? Your hypothesis was correct, and plants do grow faster in sunlight. Now it's you guys' turn. I'll give you an example. So imagine this. You want to find out if chocolate will melt faster in your hand or your pocket. Does anyone have an idea about what the hypothesis will be?
Um, so I think that it would um like melt in your hands. So
That
because
is, oh, sorry. I have it each mapped out, so you'll get a chance to answer each,
okay.
I promise. Um, yes, what you said is correct. Your hypothesis was that chocolate will melt faster in, you said your hand. You could have also said in your pocket. It doesn't really matter which, what, of course, it's a hypothesis, so it's just what you think. So either way, you are correct. Now, what do you think, or give me an idea of what you would do for the experiment to find out if your hypothesis is true.
Um, so I would just test it out. So one in my hand and one in my pocket.
Yes, that is also, you're on a roll. I said that, which is what you said, time how long it takes chocolate to melt in your hand versus in your pocket. Now, let's say that the chocolate melts in about 70 seconds in your hand, and the chocolate melts in about 160 seconds in your pocket. So it takes longer for the chocolate to melt in your pocket than it does to melt in your hand. What's your conclusion? Again, the conclusion is saying what the experiment proves, but it's also just determining whether your hypothesis, your initial guess was correct or not.
Uh, 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 okay, so the conclusion is that wait, I forgot. I'm sorry.
No, it's okay. I can go back. Just to remind you, you said that your hypothesis was that the chocolate would melt faster in your hand. And here it shows in the experiment that we performed, it shows that the chocolate did melt faster in your hand than in your pocket. So what can you say about the conclusion? Was your hypothesis correct or was it incorrect? It's okay. You'll see that chocolate melts faster in your hands than in your pocket. So your hypothesis was correct. But let's move on. I know I just said imagine this, but imagine this again. You have one target, one bullseye, and you start throwing darts at it, and they land here, here, and here. Then you get another target, and you throw more darts at it, and they land here, here, and here. And finally, you have another target, and you throw darts at it, and they land here, here, and here. Now, I just want you to keep this image in mind because it's a really good example of what I'm going to talk about next, which is accuracy and precision. Both are very important measurements to perform in science. And accuracy it just means how close you are to the correct or true value, which in the bullseye terms, which means how close are you to hitting it in the center. Now, on the other hand, precision means how close your repeated results are to each other, which basically just means are you hitting the same place? If we're talking about the bullseye, are you hitting the same place every single time that you throw the dart?
No.
So, this brings the question, can something be precise but not accurate? You don't have to answer it yet because I'm gonna show you this image again. So, now that you know what precise and accurate mean, what can you say about the darts on this first target? Would you say that they're accurate? Would you say that they're precise? Would you say that they're neither? Would you say that they're one and not the other? What do you think? If you want me to go back to the page where I have the definitions, I can.
Yes, please.
Okay. I'm sorry, that's my fault. I should have given you some more time to write them down.
It's fine. Okay, I'm ready.
Okay. So what do you think yeah, that about the first target?
It's like accurate.
Yes. Good job, good job. Now, what do you think about the second one?
Uh, precision, I think.
Yes, that's also right. Good job, good job. And then what do you think about the very last one?
It's precise.
Is that it? Just to remind you, accuracy is also like how close they are to hitting the true target in this case, or in more broader terms, just the correct value. And if you apply that to this bullseye, that means how close are you to hitting the center? But this one, it hits both the center and it hits the center repeatedly. So what would you say about it?
Accuracy,
And precision. Yes.
both, I guess.
hmm So this brings us back to our original question, which was, can something be precise but not accurate? Just a little hint, the second bullseye. What do you think?
I think right now, I think that it could be either one.
I just wanted to show you again. What did we say about the second one? The second bullseye.
Oh, oh yeah.
It's all good. It's all good. But yes, a couple of more examples. 'Cause I know that there's more examples than just the bullseye. So another example of something being precise but not accurate is, let's say you have a rock and you want to weigh that rock over and over again, and you weigh it at least 7 times. And every time you weigh it, you get that it's 2 pounds, but the actual weight is 3 pounds. In this case, we could say that it's precise because you're getting the same measurement over and over again, but the true weight is 3 pounds, so it's incorrect, which means that it's precise, but it's not accurate. Did that help you understand it better?
Yes, thank you.
Okay. Now, scientists use a lot of different tools to help them observe and measure. And in this table, we have some pretty common tools. We have a ruler, which helps them to measure length. You have a thermometer, which helps to measure temperature. A scale, which helps measure mass. A microscope, which is used to see substances that are too small to see with just your eye alone, so it enhances the photo. Yes, you raise your hand.
Um, so so um, we learned this at school too.
Oh, okay, okay. I'll just move on then. So what I'm going to talk about next is really important, especially in the experimentation part of the scientific method, which is safety rules. And these are some of the safety rules that are just basic for most times that you'll be in a lab setting. It's really important to wear goggles and safety equipment, to never eat or drink anything, to always tell the teacher if there's any broken instruments or just something that's unusual, to always read the directions of the lab before you do anything, and to always wash your hands before and after lab. Yeah. I'm just going to ask you a question. Why do you think that safety rules are important in lab?
So the safety rules are important because so we can be protected and be in our safety.
Yes, yes, that's exactly right. To protect yourself and to protect others. Can you guys see my screen again? I think you should be able to see it. So for all these classes, for mine at least, I'll have these exit tickets, which is basically just a few questions that I'll ask at the end of or towards the end of our sessions. And if you've been following along with your guided notes, you can use them to help you. So back to the first question that I asked. After hearing the lesson for today, what do you think science is?
So can you so can you please
Go back.
give us uh the booklet code, please?
Oh, we're gonna do it. We're just gonna do it after the lesson's over. I just think it'll be easier that way.
Okay.
Did you hear what I said though about the exit ticket? I don't know if you were here.
Um. Yes.
Okay. Basically, yeah, it'll just a few questions that I'll ask you about what I've presented in the lesson at the end of our or towards the end of the lessons to just make sure that you know what you're supposed to have taken away from what I said. Now that I've said it already though and taught it in the lesson, what's your newly informed definition of science? What do you think it is?
I think that science is like to help change the world and to make the the world a better place.
Okay, okay. So whenever I was presenting, your definition of science is more of what it can do, which I definitely agree with. But just to define science as what it is, we just consider it a way of learning about the world through asking questions and doing experiments and such. Okay, the next question is, what are the steps of the scientific method?
So the first step is um I forgot. I'm so sorry.
Oh, it's okay, it's okay. Okay, so are you actually able to write on the guided notes that I sent?
No, it did not let us.
Oh, okay, okay.
So I think um like I was trying to tell you the scientific method since I remembered, but like it was before you put it on. It
No,
was
I know, I know.
Salome was talking and I didn't like so
It's okay, it's okay. I'll try to make the next one that I send, or rather, is it allowing you guys to download it, the PDF?
no.
Oh, really? Okay.
Yeah.
It's okay then. I'll try to send like an editable version in the group me whenever I send a link in the chat. No
Okay.
worries.
Okay.
Okay. Um, so yeah, we got that. I'll go back to where I was at the end. Okay. Oh, sorry. I'll just show it. But if you ever do forget though, even if you know, have written it down somewhere, then it's best to just think of it like how we defined science earlier, by, you know, a way of asking questions and, you know, doing experiments. The first step really is just to ask a question. Find something that you want to learn about and just have a specific question to ask. Afterwards, just, you know, compile things that you already know about it. And afterwards, you can make a hypothesis of what you think to be true about the question you asked. Afterwards, you just find a way to test it. You make an experiment. You perform the experiment. You collect any data or observe what happens. And afterwards, you just analyze the results and draw a conclusion from what you did.
Okay.
Okay. What is the difference between accuracy and precision?
So accuracy is like the one that like is right right like it's close to yeah, each other but it's not like so that I think like the difference between accuracy and precision is that like accuracy refers to like how close the how close is measurement is to uh like a true value, and
Yeah,
and precision is like how it refers to it. Precision refers to how close measurements of the same
yeah,
items that are are, are to each other. And
yeah.
my my friend, she left because someone came,
Okay, no worries.
but
But
she'll come
yes,
back.
that is correct. Accuracy is how close a result is to the true value, and precision is how close results are to each other. That is correct. Okay, I know that your friend left, but we can, maybe ask her when she comes back. But can you just name two of the tools, and what they measure?
One tool is a ruler, and a ruler measures how the length and the inches.
Yeah.
And my friend is here, so she could say one thing.
Okay.
Yeah, and it just it measures the the things of of stuff, and the the another tool is another tool, and it checks how hot, and yeah, and how cold.
Okay, okay. You guys mentioned the ones that I put, which is ruler, which measures length, and a thermometer, which measures temperature. So, you guys got that one. Oh, sorry. Do you guys have any questions for me?
Yes.
Okay.
So, why do the people where so why does the people wear the goggles for science?
Mm-hmm. I'll go to that slide.
And 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 also, so why, like so 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 what is that's that 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 stuff that they mix up
Okay, okay, okay.
with the other stuff,
Well, I see what you're talking about. I see what you're talking
yeah.
about.
So I
Okay. So I don't know if you asked me to just go to the slide with the goggles or to explain why we wear goggles, but uh, just to also further introduce myself. Last year, in high school, I actually took AP chemistry, which is where we get to do all the fun stuff, where we mix chemicals. And the reason why we wear goggles is because some of the chemicals we work with are pretty dangerous.
oh,
Sometimes
okay.
with different types of acid, and we don't want that to be able to, splash into our eyes and things like that. We also wear aprons, and that's because we also work with fire. So we light these things called Bunsen burners, and we use that to heat up some of the chemicals we use to cause a reaction. And we don't want anything like our clothes or maybe our hair to catch fire. So we have that. We also sometimes use basically these kind of gloves whenever we touch things that are hot to make sure that we don't burn ourselves. And since you guys were asking about chemicals, I'll go back to the video I had in the first slide. Can you guys see the video?
Yes.
Okay, yeah. So these are some pretty cool reactions, it looks like. Um, but yes, if you guys ever take chemistry in high school, then you guys will get to do a lot of fun experiments.
Oh,
Do you have any other questions? It can be about
uh,
any.
so yes, my friend, she has a question for you.
Okay,
And by the way, um, but thank you for answering my questions.
no problem. That's what I'm here for.
So, it's my question is about the sky and stuff. It's
Mm-hmm.
how does it? Why is the sky blue, but does it help plants grow? If the sky is blue.
The sky is blue to help plants grow. Okay, so there are two different. If your question is why is the sky blue, then it's actually a deceptively hard question. Maybe you've heard it before, but if someone's ever asked, "Oh, well, why is the sky blue?" And they've answered, "Oh, it's because, the sky reflects the ocean, and so the sky is blue because the ocean is blue, and a big percent of the earth is just water." But it goes just a little bit deeper than that. Um, Basically, to explain it in really simple terms, you guys know how, the sun's up, and have you guys ever been outside and you feel like you can feel the sun, hitting your skin, it's so hot?
Yeah.
Okay. That's because that's just how sunlight, interacts with the earth and the sky in general. And so basically, whenever you know how air is just all around us?
Yeah, but you can't see.
You can't see it, that's right. Basically, the sunlight interacts with the air, right? And basically, have you guys I don't know how far you guys are in science, and I'll actually be talking about atoms and particles in my next lesson. But to give you guys just a little preview, do you guys know what an atom is?
Yeah. No.
Okay. I'll just give you guys a quick definition. Do you guys know what a particle is?
Yes.
Okay, so just imagine that in the sunlight that you feel hitting your skin, right? There's a bunch of little particles. And in the air that's all around us, there's also a bunch of little particles. And so basically, blue light, which is, the color of the sky is, it scatters, right? It interacts a lot, and it interacts more than all of the other colors, which is why we see the sky as blue to our eyes.